Hey guys, it's Ms. Kreisman, and today we are going to be talking about chemical reactions. So your goal for today is to be able to determine whether a reaction is physical or chemical by using the City Girls mnemonic device. Okay, so this notebook page has been added to your digital notebook. So for today, while you're watching this video, you just need to listen and focus on the video. You don't have to actually write the notes. It's already in your notebook for you. So first of all, we are going to review what a chemical reaction is because we're talking about what the evidences of a chemical reaction are. Okay, so here's the definition. A chemical reaction is the process of mixing substances together in which new substances are created. Okay, so the two most important things about a chemical reaction is it has to involve mixing two or more things. It cannot be a chemical reaction if you only have one ingredient, okay? You have to have mixed something, and it has to create something new, chemically new. It cannot be the same substance. It cannot have the same chemical formula, okay? And so this page shows you all the different evidences of a chemical reaction. So we are going to break it down one by one, but just know that that page is in your digital notebook for you. Okay, so before we go over the evidences of a chemical reaction, here's a trick that's going to help you remember them as we go. Okay, so this is a trick we use. It's called a mnemonic device. That just means it helps you remember something. So the sentence is, city girls really love their phones. City girls really love their phones. So the first letter of each of those words stands for one of the evidences of a chemical reaction. So this is how you can make sure that you remember all of them. Okay, city girls really love their phones. So we are going to start with the C. This is also written at the bottom of your notes page. City girls really love their phones. So you would see, if you look at the notes page, it goes in order. C, G, R, L, T, P for city girls really love their phones. Okay? So that is there, so you can remember that. Before we get started, I want to talk briefly about how to make proper scientific observations, okay? Because part of figuring out whether a reaction is chemical or physical is based on making good observations about the starting ingredients, and then that way you can make observations about what changed or didn't change in order to make a conclusion, okay? So when you're making observations about substances, you should include several things. First of all, you should include the color, red, orange, yellow, green, blue, colorless. Okay, there's all kinds of options. And the opacity, whether something is clear or opaque. Okay, clear means that you can see through it. Clear is not actually a color. So for example, this glass up here, it looks like water or some other clear substance. But to describe this scientifically, I would not just say clear. Okay, it is clear, but that answer is incomplete. It's clear and colorless because clear is not a color. If you look at this one, this is technically also clear. You also would be able to see through it, but it's clear and blue. So there's a difference between clear and the color. So anything that is clear like this would be clear and colorless. This is clear and blue. Now, if you cannot see through it, that would be called opaque. Okay, that looks more like this. So this one is clear and colorless. This is opaque white. Okay, opaque means you cannot see through it, kind of like think of more of like water would be clear and colorless. Milk would be opaque and white. So it's more of a milky type of color than a clear color. You also want to include the state of matter, which means is it a solid, liquid, or gas, and the temperature, okay? Now that doesn't mean you have to actually take a thermometer and measure the temperature each time, but you should think about that as one of the properties of the substance. So you might just feel something to determine whether it's at room temperature, it's cold or hot, because that way you'll know if the temperature changed during the reaction. Okay, so those are all things you want to consider when making observations. Color, opacity, meaning is it clear or opaque, state of matter, and temperature. Okay, so our first evidence of a chemical reaction is a color or odor change. Now, the thing about chemical reactions is, remember, it has to involve mixing two things, and it has to be unexpected, okay? So let me show you an example of a color change that would not be a chemical reaction. Color or odor changes are chemical reactions, but let's say I have this beaker of water, okay? This is clear and colorless, it's just water, and I have food coloring, I have green food coloring. If I add food coloring to my water, green food coloring plus water, I would expect that my water is probably going to turn green. Okay, so let's see what happens. So, my water does in fact turn green. This is what I expected to happen. So, I'm not getting anything new. So this is a color change of the water, but it's not a brand new color. So this is just a physical change. I already started with green and I get green, okay? In order for it to be a chemical color change, it has to be a brand new color that you didn't originally start with. So let me show you an example of that. Okay. In this picture, you can see they started with a clear liquid here and a clear liquid here, and as they poured them together, they got a yellow substance. That would be a chemical color change, because if I were to pour two clear things together, clear colorless liquids together, I would not expect for it to turn yellow. I would just expect it to stay clear. Okay, here's another example, something blue and something yellow. Now, if you pour together something blue and yellow, think about art class. If you mix blue and yellow paint, you're going to get green. So if this had turned green, that would not be chemical, because that would have been what I expected. But it turns pink, which is a brand new color that I would not have expected. So that is a chemical color change. Okay, another type of evidence for a color change is odor change, or evidence of a chemical reaction is an odor change. So one example is something like a rotting egg or a pie baking. Usually when someone's cooking, you can smell it all throughout the house. So cooking and baking are always examples of chemical reactions, because usually there's an odor change and there's usually a color change. When you put a pie into the oven, it's usually a pale color and then it gets darker. Okay, so I have one more example of a color change to show you. Actually, two more. So this first one is with a substance called milk of magnesia. It's something that you can find at a pharmacy, okay? And let me go ahead and show you. This commercial for milk of magnesia.
You know, it's not something we talk about.
So that's just kind of funny. But milk of magnesia is a substance that helps soothe your upset stomach by changing an acidic environment to a basic environment. So this is having to do with pH. So acidic means that's when your stomach hurts. Basic is more normal. So it takes your stomach acid and neutralizes it. So let me show you a video of this chemical reaction. So in this beaker, I have milk of magnesia and water. Milk of magnesia looks just like milk. It's white and opaque. And then obviously water is clear and colorless. So when I mix those together, it stays, it just stays white and opaque. So no chemical change. That's just physical. I was mixing two things together. Nothing really happened. Okay, now I'm going to use universal indicator, and hopefully you can see through, you can kind of see it's a green color, so it's clear and green. When I pour it into the milk of magnesia and water, I get purple. Okay, so that's the first chemical change. I had green and white, and that makes purple. That would not be what I would have expected. I would have expected probably just a lighter color green. Now I'm going to add some vinegar. Vinegar is clear and colorless. Okay, and I would probably expect when I add the vinegar for nothing to really change because it's just clear. But watch what happens. So in this reaction, the milk of magnesia actually goes all the way through the rainbow. You can see when I first add the vinegar, it turns red, and then it goes orange, yellow. Here's orange, yellow, green, blue, and kind of back to the purple color, okay? So that is obviously a chemical reaction because I would not have expected any of those colors from just adding vinegar. Okay, here's one more example. We're going to do this one. In this example, I'm using universal indicator. That's the same thing I just used in the last one, which is green and clear, and then acetic acid, which is clear and colorless. And all I'm going to do is mix them together. And I get a brand new color. So it actually turns red, or kind of a pinkish red. So again, since that's not what I would have expected, that tells me that's a chemical change because it was a color change and it was an unexpected color change. If I mix something green and clear, I normally would just expect that to be maybe a lighter color, but this turned a whole new color. Okay, so that was not what I expected. Okay, my next evidence of a chemical change is gas and bubbles. So anytime you see bubbles, that's actually an indication that a gas is being created. So that's why gas and bubbles go together. Okay, so anything that you mix two things together and you start to see bubbles, that would be an indication of a chemical change. Here's an example where they mix something in this bottle and it starts blowing up the balloon. That's an indication that a gas is being formed because that's what's making the balloon fill up. Okay. Now, let me show you one example of something. Okay, when you put water on the stove to boil, that's another time where you might see bubbles. So we see bubbles here in this beaker. However, think about why this would not be a chemical change. Okay, so we do see bubbles, but do you remember I said in a chemical change, first of all, you have to have mixed two things together. I didn't mix anything with that water. And it has to create a new substance. That's not creating a new substance because it's just water. There's nothing else being added to it. It's just boiling and turning into steam, which is still H2O. Okay, the next one is rust, corrosion, and tarnishing. So rust is when metal oxidizes. So if you've ever left your bike outside and it rains or something, you may have seen rust or a rusty nail or a rusty chain and it gets that brown color on the metal. That's also a color change, so that's another reason it's a chemical reaction. Okay, corrosion. You may have seen this if you've ever had a really old electronic device like an old remote or something that uses batteries and you see this white crusty stuff on it. That's what corrosion is. And then tarnishing. Tarnishing is something that happens to silver. Ladies, you've probably seen this happen to your jewelry before, where it goes from silver and it starts turning black and it gets this gross stuff on it, okay? So most of these, tarnishing is also a color change, which is another reason it's chemical. So just remember those terms. If you see rust, corrosion, or tarnishing, all of those are chemical changes, okay? And then light, burning, and smoking. So any type of reaction that produces a light is chemical because that light usually means something's burning. Okay, so this is a reaction where they mix something together and it gave off that bright kind of purpley light. Okay, that light tells you that something is burning, which is evidence of a chemical reaction. Then obviously anything that's just straight up burning, like a log on fire, or anything that smokes, that would also be an evidence of a chemical change. So let me show you one example of that. I normally would show you this in class, but unfortunately, you aren't here. Okay, I'll show that one more time. So this is a particular chemical that I drop over the flame and it ignites and catches on fire. Okay, so that's a chemical reaction because it is burning. Okay, so our next reaction is a temperature change. Okay, and just like color change, this has to be an unexpected temperature change in order to be a chemical change. Okay, so anytime I mix substances together, any chemicals together, and they get hot or get cold, that would be a chemical change. Okay, one example is these instant cold packs. You may see these if you play sports. They usually use them outside on the field because we don't have freezers outside. So these cold packs, sometimes you'll see them too in first aid kits. They have packs of chemicals in them, and so what you can do is you can break them apart and that breaks open the chemicals, and so when you shake it up, it gets cold and it can be used as a cold pack. Okay, so let me show you an example of that. This is a chemical called citric acid. I accidentally labeled it wrong. And water. So the citric acid is just a white little crystal. It's a solid. And then the water is a clear, colorless liquid. So I'm just going to pour the water into the baggie to mix them together and see what happens. So I'm just mixing it with my fingers. Okay. Now, the citric acid is just dissolving in the water, but as I'm touching it, I can feel that it's getting cold. So the water was room temperature, the citric acid was room temperature, but when you mix them together, they get really cold like an ice pack. Obviously, you can't really see it from the video, but you'll just have to trust me. So it gets cold, so there's no visible chemical reaction, but the temperature change tells me that there is a chemical reaction going on. Okay, now a different example. This one I showed you earlier, water on a hot plate. This one does not count as chemical because I'm changing the temperature on purpose. Okay, that's one of the reasons. So remember, the temperature change has to be unexpected. This, I did it on purpose. I knew it was going to get hot because I put it on a hot plate. Okay, but another reason it's not chemical is I didn't mix anything with the water. So remember, part of the definition of a chemical reaction is you have to have mixed two substances, and I didn't create anything new. I'm boiling the water. As it's boiling, it's turning into steam, but that's still water. The formula is still H2O. Okay, so unexpected temperature change, it has to be from mixing two or more substances. And our last one is a precipitate. It kind of sounds like precipitation, but it's not the same. Precipitation is rain. Precipitate means it forms a solid. Okay, now it doesn't mean that the whole thing turns into a solid. It just means a solid forms inside of it. Okay, so if I take water and I go put it in the freezer and it turns into ice, that's a liquid turning to a solid. That's not what a precipitate is. Okay, a liquid turning to a solid is a phase change, and that's not chemical, it's just physical. Because that water that I put in the freezer, I didn't mix anything with it, it's still just water, it's H2O. So a precipitate is actually when I take two liquids, two chemicals of some kind, And when I pour them together, it forms a solid inside of it, not the whole thing turning to a solid. It's actually kind of hard to tell sometimes. What it usually means is it looks cloudy or chunky. So here's one example. We have two clear liquids, and when I mix them together, it just looks kind of cloudy because those are tiny little solid particles inside of it. Here's another example. They're mixing two clear liquids, and you can see as he drops it, the little clouds forming. And you would probably, if you scooped it out, you would be able to see the solids on your hand. Here's another one, two clear liquids, and it forms this golden, glittery solid. And then the last one, these two are both color changes and precipitates. This was two clear liquids. When they mixed them together, it turned yellow, so that's a color change, and it formed a solid. Okay, the way you can tell it's a solid is because of this shape of this cloudy part right here. So it's not just a liquid all mixing together, it's actually forming a solid. If you took it and put it through a strainer, like how you strain spaghetti, you would be able to see those solid particles left behind in the liquid. Okay, let me show you an example. So in this example, I have milk and vinegar, and my vinegar is just dyed blue with food coloring. So the milk is a white, opaque liquid. Remember, opaque means you can't see through it. It's like milky. And my vinegar is a clear blue liquid. It's kind of hard to tell with that much liquid, but you can see if I tilt it, it is actually clear. You can see through it, but it's also blue. Okay. So now I'm just going to pour some of the vinegar into the little dish. Now you can really see clear blue liquid because you can see my fingers through it. And then I'm going to take the milk in a dropper and drop it into the dish. And you can see every time I drop it, it forms a little cloud because it's forming solids as it drops. Okay? A lot of people tend to think that this one is a color change because it kind of gets like a darker blue. But that's not a color change, okay? Because that's not a brand new color. If it just gets lighter or darker, that's not a color change reaction. This is a precipitate. So now you can see, I'm going to try to move it around so you can see a little bit. You can see in different lights, you should see all of these little solid particles. Okay, so if I stuck my finger in it, I would actually be able to see a solid on my hand. Or if I strained it. That's what a precipitate is. Mixing two liquids and a solid forms inside of it. So normally it just looks cloudy or chunky. That's called a precipitate. Okay, and precipitate is the last evidence of our chemical reactions. So remember, you have this page in your notes. And remember, city girls really love their phones to help you remember it. So city girls really love their phones. Color and odor change, gas and bubbles, rust, corrosion, tarnishing, light, burning, smoking, temperature change, and precipitate, which means to form a solid. Okay, make sure you know these and remember these. The city girls thing will help you hopefully remember it, and we're going to be practicing over the next few days. But this list is going to be what you use anytime that you have an assignment about chemical reactions or a test about chemical reactions. You'll have to use city girls to see if something's chemical. So the rule is if it's on this list, it's chemical. If it's not on the list, it's not chemical. So something like evaporating, not on city girls, must be physical. Absorbing, that's not on city girls, so it's not chemical. What's the other one? Dissolving, not on city girls, so it's not chemical. So in order to be a chemical change, it has to be on city girls, has to involve mixing two or more things, and it has to create something new. If you were to look at the chemical formula, it would be a new substance. Okay? Have a great day.